So we're going to solve some trig equations. And for these two examples, we're going to restrict the answers to be between 0 and 2 pi. So I only want answers that are between 0 and 2 pi. However, in this problem, the argument has been modified, so I'm going to have to start off with the general formulas. So let's ignore all the stuff that's in the middle right now and just think of when is cosine equal to square root of 3 over 2 within the four quadrants from 0 to 2 pi. Well, which quadrants will we be talking about? Cosine's positive, so it's not the second quadrant and not the third quadrant. So we're talking about the first and the fourth quadrant. And what would the reference angle be? Well, when is cosine equal to square root of 3 over 2? When it is adjacent to 30 degrees. So we're looking at 30 degrees. So what does that mean? Let's see, 2 theta minus pi over 4 in the first quadrant, 30 degrees in radians, would be pi over 6 plus 2 pi k. Because again, we're going to start off with the general formula. And what is the other one? We're going to have enough room. 2 theta minus pi over 4 is equal to, what is the angle in the fourth quadrant with a reference angle of 30 degrees? And that would be 11 pi over 6 plus 2 pi k, because again, we want to start off with the general formula. All right, but we are solving for theta. So we need to get theta by itself. We have two different equations that we're going to work with. So I'm going to add pi over 4 to both sides. On both equations, I might as well while I have the red pen. Okay, so we have 2 theta is equal to pi over 6 plus pi over 4 plus 2 pi k. And our other equation, 2 theta is equal to 11 pi over 6 plus pi over 4 plus 2 pi k. All right. Let's add these two together. So in order to do that, I'm going to have to get an LCD. The LCD is 12. Okay, so let's turn these to have denominators of 12. 2 theta equals 2 pi over 12 plus 3 pi over 12 plus 2 pi k. And 2 theta equals 22 pi over 12 plus 3 pi over 12 plus 2 pi k. So we've got 2 theta is equal to 5 pi over 12 plus 2 pi k, and 2 theta is equal to 25 pi over 12 plus 2 pi k. Okay, so now we have to get rid of the 2, because again, we're solving for theta. So I'm going to divide everything by 2. We'll have to get a clean board. So we're dividing everything by 2. So it leaves us with theta is equal to 5 pi over 24 plus pi over k. And theta equals 25 pi over 24 plus pi k. Okay, so we have the general formulas, and now we got to come up with our solutions that are within 0 to 2 pi. In order to do that, I think I might get a common denominator just so it's easy to add the pi over k. So this is the same as saying 5 pi over 24 plus 24 over 24 pi k. 24 over 24 is 1 with that common denominator. And 25 pi over 24 plus 24 over 24 pi k. Okay. So what would happen if when k is 0? So that leaves us just with the first solution, which is 5 pi over 24 plus 0. And for this one, we'd get 25 pi over 24 plus 0. Okay, and none of those are bigger than 2 pi. Neither of those are bigger than 2 pi. What about when k is 1? So we would have 5 pi over 24 plus 24 over 24 pi, one of them. So that's 29 pi over 24. Is that bigger than 2 pi? No. And what about this one? It would be 25 plus 24, which is 49 over 24. This would be too big. This is bigger than 2 pi. Because what would be 2 pi in terms of 24s? Yeah, it'd be 48 over 24, so that's too big. Can we go any further with this one? Let's see, when k is 2, which would mean adding another 24 over 24 to the one we just got. So that would be 24, add 24. To get that, what's that, 350 something, which is too big, so I don't even have to bother, but I'll write it down, 53. Which is too big, because again, 2 pi in terms of 24s would be 48 over 48. So what is our solution to this problem? Unfortunately, I don't have, maybe I could squeeze it up here. Our solution is 5 pi over 24, 25 pi over 24, and 29 pi over 24. Did that fit? Yes. Okay, so we have another trig equation to solve, and again, we're solving it on the interval from 0 to 2 pi. The first thing I notice is that I have a negative angle in here. I want all the angles to be the same, so I'm going to use the even-odd properties to get rid of that negative. Since cosine is an even function, I can just drop the negative. Putting a negative angle is the same as just having the regular angle. So I'm going to go ahead and rewrite this problem without that negative. And this pen is not very good. Okay, so the other problem I have is that I have sines and cosines. And I want, if I can, to make everything the same, have the same trig function. So I'm going to use an identity. I've got sine squared here, so I can replace sine squared with 1 minus cosine squared. So I'm going to replace that. Let me rewrite it. Now there was a 2 on the outside, and I'm replacing it with the whole 1 minus cosine squared. So let me put parentheses around that, so I make sure I distribute. So I've got all the same angle, everything is theta, and I've got the same trig function. So let's distribute and see what happens. 2 minus 2 cosine squared theta equals 3 minus 3 cosine theta. I'm probably going to have to factor, so let me get everything on one side and one side 0. I'm going to move the 2 cosine squared to this side, and I'm going to move the 2. So I'm going to subtract the 2, and I'm going to add the 2 cosine squared. Let's make that a different color so it doesn't get confusing. We'll make that green. I'm going to add. And I'll write them in descending order of degree and put the 0 on the right, so it's going to be nice and pretty. So I have 2 cosine squared theta, so it's over on the other side, minus 3 cosine theta plus 1 equals 0. So I brought everything to the other side, and I've got this function that, I've got this equation that I can factor. So what did I do? I still have to factor. I still have a lot to do. But I replaced the sine squared with 1 minus cosine squared because we know that identity. And I changed the angle. If it was a negative angle, I used the even-odd functions to change it to a positive angle. And I got one side equal to 0 so that I can factor. But I don't have any space, so I'm going to have to erase the board. So let's be thinking, how am I going to factor this? Okay, so let's factor this. What times what makes 2 cosine squared? Well, that'd be 2 cosine times a cosine. 2 cosine times cosine is 2 cosine squared. And what times what makes 1? That's easy. 1 times 1. Now, they have to add up. When I FOIL this out, it needs to add up to negative 3 cosine theta. So these probably should both be negative. And let's multiply that out. That'd be negative cosine and a negative 2 cosine. They add up to negative 3 cosine. Okay, good. We're good. So we have it factored. So what do? Set each factor equal to 0 and solve each of these equations. Bring the 1 over, divide by 2. So we're looking at when is cosine equal to a half and when is cosine equal to 1. All right, remember, we're just doing it on between 0 and 2 pi, so I can just look through these quadrants. When is cosine positive? Well, not quadrant 2 and not quadrant 3. So I'm looking at quadrants 1 and 4. And what is the reference angle? It looks like it is 60 degrees. Adjacent to a half is 60 degrees. So this would be pi over 3. So what 2 answers do I get from this statement? I get pi over 3. And what angle in the 4th quadrant between 0 and 2 pi, so it has to go in the positive direction, has a reference angle of pi over 3? That would be 5 pi over 3. All right, what about this one? When is cosine equal to 1? That's one of those quadrantal angles. All right, which point would that be? I think it's 0, right? 1 comma 0. This would be negative 1, 0. And in these two places, x is 0. Remembering cosine goes with x, so the angle is 0. So what's our final answer? We'll put it nice and pretty in set notation.